Born on January 8, 1942, 300 years after Galileo's death, Stephen William Hawking would challenge the deepest question of our universe. How did the universe begin? What happens inside a black hole? And can we understand time itself? Despite a devastating illness that stole his body, he used one of the sharpest minds of a generation to open the cosmos to millions. Stephen Hawking grew up in England in a household where science and medicine were often discussed. He read widely, moved from London to St. Albans as a teenager, and won a scholarship to Oxford, where he studied physics. His undergraduate work showed fluency with mathematics and appetite for the big questions: why the universe is the way it is. After Oxford, Hawking moved to Cambridge for doctoral work, joining a small community of theorists who were reshaping our view of cosmology and gravity. In 1963, while a young researcher, Hawking was diagnosed with a motor neuron disease, ALS. Doctors gave him only a few years to live, yet rather than withdrawing, he dove deeper into cosmology. He recalled later that the prognosis sharpened his focus. When you think you have little time, you ask bigger questions. Singularity theorems. In the late 1960s and early 1970s, Hawking, building on work by Roger Penrose, turned Einstein's equations into precise theorems about when singularities, regions where curvature becomes infinite, must form. These results showed that singularities are not mathematical curiosities, but generic outcomes of gravitational collapse and the Big Bang itself. In short, under broad conditions, general relativity predicts its own breakdown, an extraordinary conclusion with profound implications for the origin of the universe. These Penrose-Hawking theorems established a rigorous link between general relativity and the origin of the cosmos, framing questions that would dominate Hawking's career. How does quantum theory alter these singularities? In 1974, Stephen Hawking made what many call his most famous discovery. Black holes, according to quantum theory, are not completely black. Quantum effects near the event horizon allow particles to escape. Black holes emit radiation and thereby have a temperature. This result merged quantum mechanics, general relativity, and thermodynamics in a startling way, suggesting that black holes slowly evaporate. Hawking's calculation answered a theoretical puzzle and opened a new paradox. If black holes evaporate, what happens to the information about the stuff they swallow? This black hole information paradox would push physicists toward deeper questions about quantum gravity. In 1988, Hawking released A Brief History of Time, a short non-technical tour of cosmology, the Big Bang, black holes, and the search for a unified theory. The book became an unlikely global bestseller, bringing abstract ideas about the universe into living rooms around the world and turning Hawking into a public figure as recognizable as the ideas he championed. Hawking's life was public in many ways. His courage in living with a disabling disease, his sharp wit, and his penchant for provocative statements about humanity's future. He urged space exploration as an insurance policy for human civilization, warned about risks from artificial intelligence, and used his celebrity to highlight science and disability rights. Beyond black holes and singularity theorems, Hawking pursued cosmological models such as the no-boundary proposal with James Hartle, an idea about the universe having no initial boundary in time, a way of describing the origin of the universe that removes the need for an initial singular point. He continued to publish, collaborate, and provoke debates on the deepest questions about quantum gravity and the arrow of time. Hawking received numerous honors, from fellowships and medals to international prizes and popular accolades. More than awards, his legacy is the way he reframed all scientific conversations and inspired generations to look up. Stephen Hawking died on March 14, 2018 at age 76. In this adult life, his ideas continue to ripple. From technical research into quantum gravity to public imagination, he taught us that physical limitations are not capped to reach of a curious mind. Hawking asked the oldest questions, and in doing so, he made the universe feel a little closer to home. Thank you for watching. See you next time.